Thank you all for joining me in the platform engineering track. My name is Safir, and I will be talking about infrastructure knowledge graphs in platform engineering. Quick introduction, my name is Safir. I'm a principal engineer at MoEngage. I've been in the domain of SRE for last 20 years. So this talk is aimed at providing you with the thought process on how to model your platform's cataloging capabilities, right? And there is no technology or solutions that we are going to propose here, but rather it's going to be a mental model on how to organize your software infrastructure as a thought process, right? And this image is taken from the CNCF white paper on platform engineering. And as you can see, it lays out all the components, what is there, and this is the summary of the definition of platform engineering, right? But what is really, what makes a platform? Now, if we condense all what we saw in the previous slide and in the white paper, it comes down to two objectives and three core components. Get information, get things done, and then, of course, there are three components. The first one is the IDP, or the internal developer portal. And then there is a software catalog, which is the catalog of all your software infrastructure entities. And then you have automation on the other side, which provides the value of automating your developer workflows, making your developer's life easier. Now, these are from the white paper itself, right? These are the platform goals, or on what should companies aim to achieve with platform engineering. Now, if you see it here, it touches upon the entire spectrum of software engineering and producing software, right? But there is always a general tendency to put all these goals under the single umbrella of developer productivity. So are we too much focused on developer productivity? Now, this might sound a bit controversial, but allow me to explain, right? See, developer productivity is definitely one of the primary goals of platform engineering, no doubt about that, right? But productivity the productivity doesn't improve in a vacuum, just on its own, all right? And in our quest to improve the productivity, we are actually missing out on something very basic, and that is operational excellence, right? So operational excellence is oftentimes forgotten or deprioritized in our platform engineering journey. So it's the practice of building and running reliable software systems, and it covers, if you look at it, right, it covers the major goals of platform engineering. So what is the biggest challenge for operational excellence? It is the complexity of your infrastructure. Where all it is spread across. You will have different infrastructure vendors, you will have different platforms, you will have different SaaS, right? So this is what I would like to highlight, right? If you distill the broad goals of platform engineering, it all boils down to one overarching goals, that is engineering excellence, all right? And engineering excellence has two key pillars, which is developer productivity and operational excellence. And we know in order to achieve engineering excellence and especially operational excellence, right, the operators and the engineers has to have a full view of their entire spectrum of infrastructure, all right? And that brings us to the concept of catalogs, right? I'm hoping all of you know what is the service catalog that you already saw backstage, and the cataloging model, right? So in the rest of the talk, we are going to talk about catalog and how to model it effectively. So what is a software catalog? It's a centralized system that keeps track of your ownership and metadata. It's sort of an inventory of all sort of entities in your infrastructure. It's not just about your clusters or VMs, all right? It is more about anything and everything that a developer or an engineer touches upon, right? And the real value of a catalog is in connecting all these entities from different sources of infrastructure, SaaS, all sort of components, and deriving the value by looking at all the relationships, implicit and explicit relationships within that catalog. Now, what are the typical challenges with your software catalog, right? So in a lot many cases, there is limited context and visibility. So the catalog offers insufficient information about the services, what is their surrounding ecosystem. And it sometimes lacks the connections, what is the services downstream, what is upstream, what are the related incidents, things like that. And a lot many times, it also falls out of sync with your infrastructure. Let's say you are importing data from different sources, like your cloud provider or your Git, and you do it once a day. By the time a developer tries to operate something on your IDP, it's already out of sync, and that causes a problem with adoption, right? Now, a lot of these problems that I covered in the last slide, right? It could be a problem with how do we model our catalog and what all information we bring into the catalog, right? So there are two ways to look at it. One is fixed data model, and the other is flexible data model, right? And fixed data model provides a standard structure with predefined entity types, relationships, and it simplifies tooling. But it also limits the customization and flexibility. But if you look at the flexible data model, it supports all sort of extensibility, custom entity types, and it can better adapt to your organization's evolving needs. If you look at the comparison, this is how it would look like. So a flexible data model gives you far more control over how you model the catalog. And it can also be tailored to your organization, because every organization has its own signature, right? The way you do things might be different. Even if you use the same tools, it might be different from a different organization, right? And it also allows you to have richer analysis, automation, and everything else on top of this data model, because it's all connected, at multi-levels. Now, fixed data model. It provides, so the good thing about a fixed data model, right? It is simple. You know the data model, and it's very easy to build and integrate tools, right? And that also reduces the time to adopt the solution. And even the integration with external sources becomes easier, because it's very easy to find some data source and try to map it into your catalog data model. Now, so if you examine your catalog data in, you don't have to look at the actual data, but think about it, right? It pretty much resembles a graph rather than a table. It might look like it's a list of services or a list of cloud resources, but if you look at the bigger picture, it is a graph, right? Now, it is also possible to model your catalog as a relationship, a relational database model. But the problem is, once you start building relationship at multiple levels between multiple entities, it gets complicated really fast, right? In contrast, if you are using a graph, let's say, it's quite easy to evolve it to your needs, to your organizational structure, or your needs based on that, and it can evolve organically. So I keep talking about flexibility, right? And why do we need flexibility? So this is a quite simple representation of part of your catalog, right? If you have microservice architecture, this is how it would look. Every microservice has its own Git repo, and those Git repos are part of a GitHub organization, right? So if you have to put all your, if you connect your catalog into your Git provider, this is how it would look, right? Now the problem is, just think of a monorepo. Not everybody is going to use full-blown microservice architecture. So if you're using a monorepo, you are going to have multiple services, libraries, all coming out of the same repo from different paths, most probably, like the way you organize in a monorepo, right? In this case, the relationship changes a little bit. Earlier, the relationship between a service and a Git repo was one-on-one, right? Now it is many-to-one. And what defines the differentiation between all these relationships? They are all related to one GitHub and Git repo, but there's a path which distinguishes these relationships, right? Same relationship, different property, right? Now, let's zoom out a little bit and then zoom in on one single microservice. So again, the top row remains the same, but once you have the Git repo, every Git repo would have one or more pipelines defined against it. CI pipelines, right? And that CI pipeline definition comes from your CI systems. Now, once you run the pipeline, it produces an artifact, most probably it's going to a container registry, and which your CD system would pick up and deploy into Kubernetes. Now, that deployed service would use a bunch of resources from cloud or somewhere else, right? If you look here, I've quoted an Amazon managed RDS service, database service. There's an object store from AWS S3, and then there is a self-managed Kafka. hosted on VMs, right? Now, this is again like, a small picture of like, how it would look like. But if you start zooming in, right, the Jenkins CI, if you know Jenkins, it has its own user data model, RBAC. So you have, if you look at and zoom in and like, try to break up things, then there is users, groups, folders, and other things coming into picture. Even on the Git, right, if you are using GitHub, you have an organization and repos, right? But if you are using GitLab, there is going to be groups, namespaces, sub-namespaces, and things like that. The same applies to your artifacts. You have a container registry, but what if you are developing a Java plugin with which goes to Maven repo, right? Things like that. And Kubernetes again, like even for a single deployment, you have a whole bunch of entities like namespaces, ports, services, config maps. Everything comes into picture, right? It all again. We can do all these things, but it all ultimately depends on what exactly you want to do with the catalog. Just adding everything into the catalog doesn't make sense. So import what you want to import, right? But that is why the flexibility matters, the freedom to do what you want to do. Now, the focus of the talk was knowledge graph, right? So what is a knowledge graph? So it's a network of real-world entities and their relationships. So if you look at it, these entities could be anything. It could be physical objects or events, situations, or even abstract concepts. If you look at a microservice definition, ultimately it's an abstract concept that okay, I'm going to provide this kind of a service using this microservice. It becomes live only when you have a code and you start deploying it, right? So there are physical entities and there are going to be abstract concepts, all of them put together in a relationship, right? Now, the other thing is converting the implicit knowledge into explicit knowledge. So what is the implicit knowledge? What we call tribal knowledge in our teams, right? There would be somebody in your team who would know how a specific set of things work, and that is the only person you would go to figure out things, right? But when you start plotting some of your infrastructure, how they are related, how some of the configurations are related, things like that, some of this implicit knowledge will start surfacing. And that makes the job easy for the rest of the engineers, right? And one of the well-known examples of a knowledge graph is the Google Knowledge Graph, which stores billions of facts and their relationship between each other. And there are multiple ways to represent knowledge graph. So the easiest way is to use it as a property graph. Property graph essentially is you have nodes or entities which has its own properties, and then you connect those through a relationship or an edge, which also has properties, which is not very common in in a regular graph, right? You have a relationship that you are defining from A to B, and that relationship itself has some properties, all right? So moving from here, let us just look at how a knowledge graph would look like, okay? So all these round circles are basically entities, all right? So on the left side, you have an entity type of person, that's me. And if you look at this conference, I'm talking at this conference, the talk in itself is another entity type. And then there is, this talk is happening at KubeCon, which is a type of conference. And then it is run by Linux Foundation and hosted in Hyderabad, right? So all these are different type of entities in a knowledge graph. And if you look at the lines between them, they are relationships or edges in the graph, right? Now I'm presenting here. So if you look at the presenting, right, I'm a first-time speaker in KubeCon. So where do I put that information? Now I can put it somehow in to say that Safir is a first-time speaker in the Safir entity, right, a person entity. But does that property applies to every person, person of type, person type, right? It doesn't. So that data will have to go as a property on is presenting. The same would happen with hosted by, right? I might speak in different conferences. There will be different conferences where you would attend, we would attend, right? So again, some of those properties would go into hosted by. So let's come here, right? I have my friend Srijit attending the conference here, right? So we were friends for 20 years. Where do you put that 20 years? I cannot put it in, again, the entity type person. Why? Because I will have hundreds of friends and adding a property for each of them in that core entity doesn't make sense. It has to be on this relationship or the edge that you have to put that entity, right? Now, like that, let's try to expand this graph a little bit. So if you expand it on that side, you will see that the Linux Foundation itself has different foundations under it, and they manage different projects, right? If you come here, we are in Hyderabad. There's a restaurant named Bawarchi, which offers biryani, and I love biryani, right? So all these are facts, which I'm building as a graph. Now, this graph makes sense to me because For me, even biryani is very important. For you, as an attendee of this conference, not necessarily, right? For you, what is important is you are in this conference, there are different tracks and there are different talks. So if you are building a knowledge graph about KubeCon, it's going to be looking at the upper right corner of this graph, right? So that is the thing about knowledge graphs. You can build as much as you want, but you need to focus on what exactly is that you require. So again, when we come to knowledge graph as for software catalogs, right? Typically, a knowledge graph covers a specific knowledge area, as I was mentioning. Pick what is relevant for us, right? In the case of software catalog, that knowledge area is your software infrastructure, and your catalog entities are basically the nodes, and the relationship between those entities is the edges in the graph. Now, how do you go about building a knowledge graph for your entities, right? You have to first identify the entity types. Typically, it would be services, repos. You can think about, on a day-to-day basis as an engineer, what would you touch upon as a software entity? All of those are entities, right? And then figure out, what kind of metadata would be part of that, entities. So think about, let's say, you have a cloud, let's say AWS, right? You import those resources into your catalog. Now, you can import all of those entities as general cloud resource, which would have very basic information like, your ID, the resource ID, resource name, and probably resource type, right? But you cannot fit all the information that you want. Again, it depends on what you want to do with that entity. If you want to do some meaningful action about a specific entity, say a VM or a load balancer, then you need to import them as a specific entity. Like, rather than a cloud resource, it has to be cloud VM or a cloud load balancer, right? So you need to pick and choose what you are going to do. Based on that, you have to model your data. And entity metadata, or a property of an entity, right? It could either be a property, or at some point you could develop it as a relationship. How? Consider this case, right? You are defining a microservice in your catalog. One of the primary properties of that microservice is going to be the GitHub repo, right? Now, it could just be a text field as a property. But if you just want to know that information, or provide that information to your developers, right? But think of a scenario where you want to look at what are the PRs open against that repo, or what is the security scanning tool, or depend about saying about this repo, things like that. Then you need to find convert that property into a relationship, create an entity type called GitHub repo, create an entity type called PR, and try to relate them. That makes your job easier to traverse through that graph and figure out what is where, what you want to do, right? Now, if in the case of relationships, right, the relationships could be in different ways. Like, it could be unidirectional or bidirectional. The cardinality, or whether it is a one-to-one relationship, one-to-many relationship. So whether your catalog can accommodate those kind of varied type of relationships is something that you will have to think about. Now, in the open source world, there is only one catalog tool that you can think about, right? That is essentially the Backstage, which is the only open source framework that is available to build platforms. And Backstage, of course, offers a catalog with a data model. Now, this data model is somewhat fixed if you look at it. Backstage actually offers ways to plug in and bring in new type of entities, build a new type of entities, right? But for the core entities, it is pretty much like anything that is a software goes into components. Anything that you use as a resource goes into the resources, and all the components either consumes or uses an API or offers an API, and all of them maps into a system, which further maps into a domain. That is how the catalog data model for Backstage works by default, right? And there is no other equivalent tool in open source that I can show you for comparison and contrast. But this is a project from OpenSSL Foundation. It's a security tool. Autolius is a security tool for mapping vulnerability informations. Now, again, mapping something does mean that there is a relationship to be built, all right? And that is why Autolius offers this kind of a data model, which has a whole bunch of software domains, which is based on the concept of domain-driven design. And then there are components, which is anything with a code. And then there are applications, which combines all these components and deployed into environments. All right? Again, all these data models are for you to think about how you want your data model to be. All right? Not just blindly adopt any of these models. Now, with all that behind, right, how do we go about practically looking at building your own catalog model? Now, when you are starting with the entities, of course, you first start with your code base. Look at who is your vendor. Like, It could be, most of the time it is GitHub or GitLab, or there could be, other vendors as well, or you could self-host, whatever it is. Look at that as your, first ecosystem or a system, right? Now look at that and see what are the distinct entities within that. If it is GitHub, it is going to be repos, GitHub users, GitHub groups, PRs, and things like that. So you identify what are those entities and what is the property of those entities. Now even if you once you have that, you can even look into the repo. Let's say you have a REST API. You might have added an OpenAPI spec into that repo, right? Now if you can grab that spec and create an entity type called API spec, you could actually build an API catalog or an API registry that you would use using Swagger systems or something like that. All right? So you can build that as well. So look at it from that that perspective. Now again, once you are done with the code, move on to your next system, which is your CI. All right? And CIs again could be self-hosted or SaaS, or you could have multiple systems, right? Again, look at start by looking at what is the primary RBAC mechanism for your systems, and then of course pipeline definition is going to be the core of any of your CI systems. So look at the pipeline, how it is organized. In some cases it will be projects, some cases it will be folders, and then again there are artifact stores and code analysis tools and anything else that operates on your CI that you can look at as a source of entities. Continuing, again, move on from CI to CD, look at how things are deployed, what kind of infrastructure you are deploying it on. The same code might be deployed on different infrastructure, could be on VMs, could be on K8s, or even just as functions, right, depending on what you want to do. And there are environments, data centers, or VPCs, however your physical way of deploying things. Depending on that, you will have that many entities coming into your catalog. And then you look at what kind of resources your application uses. There will be databases, managed services, other APIs. So and then of course there will be a lot of tools that you would be uniquely using in your own teams, right? Observability tools. Different observability tools will give you different ways of controlling your systems. There could be organizations within the tool. There could be groups, things like that. So bring in all those information, and that gives you more entities to look at, right? Now with that, let's look at a quick example, right? So this is just one deployment that is deployed to a Kubernetes cluster. So I have 3 kubectl describe outputs here. So if you look at it, we of course the first thing we have is a cluster, and when you look at the deployment, you have deployment. Then that deployment is in a namespace, and if you look at it, it obviously it will deploy pods which uses an image which will be pulled from a registry. Right? And then there is also a service which routes traffic to these pods. All right? So all these things you can, if you just look at your day-to-day activity, you can figure out what are the entities related to your work. All right? Now if you look at here, right, one thing you have to notice is deployment and services. Right? They are actually related. It's your deployment, how you are talking to the deployment, but there is no direct relationship between them. Rather, you have an implicit relationship where you will use selectors and labels to make that match. Right? So that is one way for you to build that relationship. You want to directly map this for this deployment, this is my service, right? So that is one way of doing it. Now again, looking at another entity which is a Redis cluster, you again have similar things. You will see the same things, but instead of deployment, you have a stateful set, and then you have persistent volumes. All right? Same thing, but again you can pull different entities from it. Now consider this case, right? The application in the previous slide is going to use this Redis cluster. Now how are you going to make that relationship map? Right? To do that, you have to look at your application configuration, which most probably will be in a config map. Right? Now you have to find that. You have to find and look for the patterns where it looks like a cluster URL, right? Cluster.local URL, and find out and map those entities. Right? So that is how you can get entities into your catalog. Now if you look at relationships, right? So you need to again find out or understand how your entities are talking to each other. And to do that, first try to find out all the relationship between the same system. Let's say you're starting with your GitHub, right? Look at within GitHub, how is it related? GitHub has owners. Git repo has owners. There are groups which have access to the repo. Then there are GitHub users who are members of that group. Things like that. So you start modeling that for each system. Then you start looking at between these systems, what are the relationships? There is a repo, there is a pipeline, which are in 2 different systems. So start mapping those relationships, all right? And then you can start discovering relationships with shared properties within entities. So if you look at the simple use case of user management, right? Let's say most of you would be using something like Okta or some identity provider, right? So you have an Okta user as the central user entity of your catalog. Now, if you have to map them with your GitHub user or email user or anything else, there's a common property called your email, which could be simply used to connect these things, right? So that is how you can build a relationship. The other option is you start asking questions about your daily work, right? Who is the on-call for this service? So how do you map that part? What are the incidents running against this particular service, right? So that is how you start building more relationships. Now, as an example, right, as I mentioned already, if Okta is your central point and you have email from the G Suite, you have GitHub user and PagerDuty, all of them have a common factor, which is your email, right? Use that to build entity mapping relationships. Now, if we make it a little complicated and look at that, okay, I have all these user entities, so rather than having one of the vendor entities being the center point of my infrastructure, I'm going to create a virtual user within my catalog and then start mapping them to all these kind of entities, right? And if you look at it, if you zoom in on PagerDuty, for PagerDuty after the user, I have also added all the entities that are available in PagerDuty. Now, if you are not familiar with PagerDuty, it is fine. It's an alerting system, right? And there's a whole bunch of things. Ultimately, what happens is there's going to be a service which will be mapped to a PagerDuty service. And this is how you will be mapping and traversing through the entire relationship and figuring out, where is the incidents mapping to this particular service, or as an on-call, is this user looking at all its incidents, things like that, right? So that building of relationship is something that you can do using this kind of entity mapping. Now, coming towards the end, right, you have properties, right? Properties could be on your entities or it could be on your relationships, right? Now, it is not necessary that you have to bring all the information that is in your source system into your catalog. Let's say, and again, coming back to cloud, right? If you have an information about your load balancer, you probably need only the critical information about the cloud balancer into your catalog. The rest of the configuration bits and pieces could remain in the cloud because you anyway have the primary ID of that entity. You can always go back to your cloud and figure out more about that entity, right? So you have to make that choice again, what you want to do with your system, all right? And again, not all properties have to bring data into the system. For example, you have a SLO dashboard or API specs that is something stored somewhere else in the system, right? You could just refer to it as a URL or something else. And when your IDP works on your catalog, you can actually show up this as an embedded iframe or something, as a visual tool, something visual or as a URL, right? And in many cases, your catalog system, whatever you choose to use, it may not support relationship properties, right? In which case, you have to move that property either to the source of the relationship or the destination of the relationship to make some meaningful information out of it. Now, combining all these things, right? If you have to look at some sort of an entity, this is, again, it might look like a Kubernetes definition. It is not. It's just YAML, and I just made it up, right? But if you look at some sort of an entity mapping, this is how it is going to look like. It's for representing a microservice, which of course has few core entities like ID, name, description, things like that. And then there are properties which are relevant for that service. Again, these are I have picked them at random. There could be a lot more information. Similarly, there are relationships of different types and shapes that we have added here. So ultimately, this is what it would come to when you are mapping an entity and modeling, trying to model an entity. You will get something like this, and of course, then there will be relationships to different type of entities. So start building this kind of a schema in your mind, or write it down. These are the entities you want in your catalog, and start building from there. With all that, towards the end, let's come to the problems of catalog, right? At the end of the day, building a catalog is an ETL problem, right? You are extracting something from your source systems, like your infrastructure, your SaaS vendors, and then you are putting it into, transforming it in some way and putting it into your catalog, all right? So it will have all the problems of a traditional ETL job. How frequently you are updating your catalogs, how you can pull the data. And especially given that you might be pulling a lot of information from your source cloud infrastructure, quota would be a biggest thing you would be impacted with. Like if you keep pulling large number of inventories every hour or something, then you will be hit with quota failures, right? So you need to look at that. The other thing is how frequently you can sync. We would wish that we will keep it in real-time sync, which is not practical, but find an acceptable compromise, how frequently you can pull data and keep updating your catalog. Because ultimately, your engineers are going to operate on this, use this information to work on something. It could be either automated, it could be manual, but if they find that this information is out of sync, then it diminishes the value of your catalog and your IDP, right? And the last one is ephemeral entities, right? Consider this case. You have a CI system where you have defined your pipeline, right? If you are, most of you would be familiar with Jenkins probably, right? So Jenkins has a pipeline definition which you can import as an entity here. That's just a pipeline. Now, when an event kicks off, it creates a pipeline run, right? There is an instantiation of your pipeline, basically. Now, that pipeline run has a validity or a relevance in the immediate time, right? You might want to see whether the pipeline failed or what happened over there. But after a week or after a month, that is not relevant, right? So if you start importing this kind of ephemeral entities as an entity into your catalog, at some point you will be left with a lot of entities that doesn't mean anything for you, right? So you need to figure out what kind of ephemeral entities, if you want to bring them, how long you want to bring them, can they be archived, can they be deleted? You have to make those kind of considerations, all right? Now with that, we come to the end of the conversation. So just to summarize what I have talked about so far, operational excellence is the key to your platform engineering success. And start building a solution that offers a flexible catalog, or use something that that's already out there. And first, you start building your data model, first in your mind and in paper, and then only start integrating them with your catalog solution, or start building your catalog solution, all right? And of course, developer experience is key for any sort of platform adoption. And most importantly, your infrastructure will keep evolving. You will bring in new systems, you will get rid of old vendors, old systems, things like that. So your catalog should be able to adapt to that change quite easily. All right? Otherwise, you will be left with stale entities and stale systems in your catalog. And ultimately, think in graphs when you are modeling your catalogs. Thank you.